Hello, in this video we will see how to determine the natural frequency of a bimetallic plate which is made of aluminum and copper, and also we will see that the natural frequency when the plate is made of only aluminum and only copper. There are several applications of the bimetallic strip which is made of aluminum and copper. You can see the application in the sciencedirect.com, or you can search in the Google. So from there you can get some literature survey on which you can say that this has been the motivation of this work. So there are wide range of application which is available in industry as well as in the some research and development field. So first we will see what are the standard dimension of the bimetallic strip which is made of aluminum and copper. So we can see that there are standard dimension available: 1 millimeter, 1.5 millimeter and 3 millimeter. So we will take 3 millimeter as a total thickness of a bimetallic strip which is made of aluminum and copper. Okay, so we will see we will solve these things in computer numerical software which is called ANSYS. So let me first clear all the screen which is there. I will start from the beginning. Okay, so in ANSYS you can see that this is a preprocessor, then solution, then post-processor. There are three steps. So preprocessor, we need to model whatever the things that we need to do the analysis. Then in the solution technique we need to define the boundary condition, and then we can solve the model. And then in post-processor phase we can take the results and we can generate the plot after doing the analysis. So in order to start this problem, we need to start from the preprocessor where we need to build the model. Okay, so I can easily define one macro. I will build a block which is 0.05 millimeter length and 0.05 millimeter width, and thickness is 0.0015. That means 50 millimeter length, 50 millimeter width and 1.5 millimeter thickness. And the second block again 50 millimeter length, 50 millimeter width, and it starts from 1.5 millimeter and it will go to 3 millimeter. So that means total thickness of the two plate will be 3 millimeter. So I will copy these things. I will come over here. I will come to the ANSYS environment. In the preprocessor I will paste over here. So my model is ready. You can see that there is two block. It has been generated. Each block is having 1.5 millimeter thickness. Now this two block is separate quantity. There is no connection between two block. So I have to join these two block, because if you see in here in this location that you will get a two line, but actually it will be one line when there will be a connection. So I will show you why it is two connection. You can see that I am selecting the line in this middle position, and you can see that two lines. So I need to make it one line so that the connection will be there between two blocks. So I will use command v glue comma all. That means volume glue all volumes. So it will start, it will glue the volume. Now you can see that there is only one line over there. Okay, so as I have glued the volume, so the numbering system has changed. So I will compress the number. Num cmp compress comma label is volume. So volume. So it will create volume number 1 to 2. Okay. You can see that volume 1 and 2 is defined. Now I need to define the material properties. Material properties. Before define material properties, I need to define the element type. I can define element type. So solid 185 I am defining. So you can see that type solid 185 it has. Now I need to define the material properties. Material properties, I need to define two material properties. One is for aluminum and another is for copper. So for the first material model number 1, I am defining, that is for aluminum: structural, linear, elastic, isotropic. So material property for aluminum I can get from one already published paper. So you can see that the aluminum material property we can take from here: 70 GPa, that means 70 Newton to the power 9 Newton per meter square, Poisson's ratio 0.3, density 2707 kg per meter cube. So I will put 70, 1 2 3 4 5 6 7 8 9, 70 GPa, Poisson's ratio 0.3, okay, and then density is 2707. Okay. Now I will define the material property for other material, that is copper. So I am adding material ID number 2. In number 2 I will go for the structural, linear, elastic, isotropic. So Young's modulus for the copper is 128 GPa. 28 GPa. One 28, 1 2 3 4 5 6 7 8 9. Okay, and Poisson's ratio for copper is 0.36. Okay, and density for copper, it's 8960 kg per meter cube. Okay, close. So you can see that two material model it has came. Now if you see both the plate or both the volume, it consists material model 1. So I need to assign any one with the copper and another with the aluminum. So before that I need to do the meshing. Use the mesh tool, line, box. Here I am having some lines, so I will select those line. Here I will select those line. Here also some line, and I can give that division 20, let's say. Okay, and here the line is there, so mesh tool, line, this as well as this you can define, let's say 2. Okay, now I will do the meshing. Volumes, hexagonal, sweep, auto, then sweep, then this to volume, and it has mesh. Okay, now you can see that if I do the E plot and I will select E list comma P, the bottom element and the top element all are showing material 1, but I need to assign one with copper and another with the aluminum. So how I can do that? First I will select any one volume. So let's say V cell comma R comma P. I am selecting the top volume. Okay, so top volume it has been selected. Now select everything below selected volume. So whatever the element concerned with that volume, it has been selected. Now I will do E modif comma P. So that means I will modify the element P call and I will assign material type, that is 2. Okay, so now if I select all, I can see that if I do elis comma p, this and this, you can see that 2 nodes with material 2 and another 2 bottom nodes is with material 1. So now it has become a bimetallic strip of 50 millimeter length, 50 millimeter width, and thickness 1.5 millimeter for copper and 1.5 millimeter for aluminum. Okay, now I need to define the boundary condition. So for in order to define the boundary condition, I need to select let's say I am defining the boundary condition as a cantilever beam. So one side of the node I need to give all degrees of freedom restriction, and cell comma r comma p. So in box I will select the nodes of this side over here. Okay, so you can see that only the, if I plot end plot, only the nodes on the adjacent on the end it has been selected. Now I will define the boundary condition. I will come to the solution, I will go to define load, then apply, then structural, then displacement on nodes, and I will go pcall and I will select all degrees of freedom. Okay, so you can see that the one side of the node it has been selected all degrees of freedom. Now I will go for solving the model. So if I want to solve this model for the free vibration analysis, let's say I need to extract first 20 nodes from this analysis. So I have written one macro for this. So modal analysis, if I running for batch mode, then you need all those things, and if you are running in APDL, then only this will enough. So up to solve I will select, then I will copy, I will paste over here, and it will solve. So you can see that solution is done, and you come to the background window and you can see that the natural frequency, it has came the first, second up to 20th mode, the natural frequency has came. So I will copy these things and I will by metal strip. So this is the natural frequency. Now I will solve the same thing with only copper. The whole plate is in spite of made of bimetallic strip, it will be made of copper. So first of all I will save this model as a bimetallic strip, save as bimetal copper aluminum .db. So it will save. Okay, now the solution has been already done, so I need to generate the result. So I need to come to general post processor, then read result. Here you need to read result by peak. So let's say I am selecting the first frequency, read, close. Now I need to plot the result, plot result, nodal solution. So let's say I am plotting the Z component. Let's say I am plotting the Z component displacement. So you can see that the Z component displacement, it has came, and this color is showing the what is the value of each location, the displacement. Okay, so I will now I will show how to do the same analysis for the copper only plate. So first I will clear the all the things. Okay, then I will bring this one, and here the below portion is with aluminum, top portion with copper, but I have to make whole plate with copper. So how I can do that? So before that I can check my material properties, material model. So I think 8960 is for copper, so material model number 2 is for copper. So I will select all, E plot, and then E mod diff, comma P. I will select pick all, that means all has been selected, pick all, and material model 2. So if I select E list, comma P, I can see that all the element it has been with material type 2. Now I can do the same exercise of the natural frequency of free vibration. Already the one side element, it has been fixed with all degrees of freedom, that means it has become a cantilever beam. So I will come to the model analysis macro. Here I will solve again. So you can see that solution is done, and the background window will show you what is the natural frequency for copper only. So you can see that this is the natural frequency for copper only. So I can copy these values, mark, copy, and I will paste over here with only copper. Next I will do the same exercise for only aluminum. That means I need to make the whole plate with only aluminum. And before going to the third exercise, we can generate the result for this analysis, that means with only copper. I will come to read result by peak, first natural frequency, read, close, and then plot result, nodal solution. Let's say I am plotting Z component stress. Similarly, you can plot every other stress, like every other parameter, like this is degrees of freedom solution, that means there is a displacement, then stress, different stress. So the icon is there, so you can generate whatever the result you need. So I am plotting Z component displacement. Okay, so you can see that Z component displacement, it has came. Okay, so you can extract this result in your for giving in your report. Here you can extract the plot. You need to come into the control plot, then hard copy to file, then JPG and landscape or portrait, whatever you need. Let's say portrait. Okay, so you can see that it has came the result. Okay, so it has came with a background as a black color. If you want to if you want to change the background, you can do these things: plot control, hard copy to file, JPG. You need to select this reversed video, then it will come with a white background. You can see that it has came with white background. Okay, now our third model that is we need to build for only aluminum. So before that I will save this second model, that is copper only. Okay, also if plot I can start from the beginning. So I will erase all. Let's say I'm starting this one. So alls if plot, and I need to change the material, all the element with material model number 1. That means it will become aluminum. So what I will do, I will do e modif comma all, sorry, e modif comma p, then p call I will change with element material 1. Okay, so you can see that all element it has become with material 1. So that means it is made of all copper material. Now I can do the same exercise. I will copy this one and I will go for the extraction of the natural frequency. So you can see that solution is done. You come to this window, background window, and you can see that this is the natural frequency. So I can copy all the things and I can paste over here. That is for only aluminum. And you can plot the results, read result by peak, first frequency, close, and then plot result, nodal solution, let's say Z component displacement. So this is the Z component displacement, and you can see that these values is difference from the bimetallic strip or the only copper. So by this way you can generate your results accordingly, and the macros and all those things, it will be there, and you can do your own analysis with own set of parameter. So thank you.